Hi everyone. It is a pleasure to have you all here for this very exciting session on 4G plus 5G UPF and N26 Handover. Your participation is indeed very much appreciated here. I am Falguni Pathak and I will be moderating this webinar today. I will be recording this session and the recorded videos will be sent to all the participants here. Taking us through the live demonstration will be Mr. Ankur Bharadwaj, who is the Senior Director Technology and handles multiple telco initiatives with 5G data plane and MultiAccess Gateway at Amantya Technologies, and Mr. Neeraj Sharma, who is the Technical Lead Engineering at Amantya Technologies. So this session will be of around 50 minutes, and if any question strikes your mind, I would request you to please type them into Q&A section and we will be taking them at the end of the session. So without any further delay, I will now hand over the floor to Mr. Ankur.
Thanks, Falguni, and pleasure to be here. And as mentioned by you, we'll be covering our converged 4G, 5G user plane function, as well as we'll talk about N26 handover. So in this session, we'll be covering first company overview, and capabilities at Amantya and the product portfolio like 5G core. What is the path or what kind of a transition is there between 4G to 5G? Then we'll talk about details on N26 handover and why it is advantageous to have it. We'll talk about different deployment, options like with N26 or without N26. Then we'll touch upon multi-access gateway solution, which is a Amantya product, and we'll walk through the demonstration. With me, my colleague Neeraj will help us with live demonstration today. Okay. So Amantya is a organization with 500 plus engineers. We have offices in US, Canada, and India. Our prime focus area is, telecom domain, and in the product offering we have 5G SA core, multi-access gateway, which is a collapsed node or converged node where we have 4G SPGWU user plane function in 5G and N3IWF for non-3GPP access. Then another product line we have is private 5G solution, which is our extra 5G product line, and network in a box, which is which helps in lab demonstration and setting up or different kind of use case scenario testing. If we talk about the solution development, so we have capabilities to develop solutions which are robotics-based 5G, which are typically on ROS platform. Then second vertical is vehicle to all kind of communication, which is typically monitored in V2X SDKs, drone applications, and AR/VR solution. Another vertical which focuses on 5G is hardware design, firmware development, and productization of different use cases. So in Amantya, we have different domain where we work. We come from a telecom background. We have other domains which are focusing on automotive and enterprise also. So coming on the Amantya 5G core, so we have different network functions which are required for 5G SA installation and deployment. Our 5G core can be deployed on premises as well as public, private, or hybrid clouds. Talking about the compliance, Amantya 5G SA core is release 15 compliant, and on interface we are compliant to release 16 also. We support low latency services when we have a deployment in local data center. Since our 5G core is CNCF compliant, so we have different options. Our core can be deployed in Kubernetes, on bare metal or VM, different kind of cloud options, which are mentioned like AWS, GCP. On throughput, we support or we have already tested in our labs with 200 Gbps aggregated throughput for data plane. And SA core, we support 100K simultaneous sessions. Talking about the advanced feature, we have network function, which is NEF, which is required for any API development, and we work with different forums like Camara, 5GFF, and MEC, HCMEC compliance also. 5G core, Amantya 5G core supports slicing, QoS enforcement, UPF relocation, UPF branching, and it is compliant to SPI interface as required by 3GPP. So when we talk about deployment from 5G, when we migrate a network from 4G to 5G, what advantages we get out of 5G transition is ultra fast speed, low latency, and support for network slicing, which enables different use cases on the same network and different quality of service parameter enforcement. And on top of it, there is enhanced security, which is mandated or required from the 3GPP standards. So now let's talk about N26, which is the focus area. So when we talk about coexistence of 4G and 5G technology, and if we talk about a brownfield deployment where 4G and 5G will coexist, so there are, when we migrate or my typical applications like voice, SMS, or value-added services are already available on 4G network. And when we go for 5G, so typical deployment, what we are observing or seeing in across the geography is that, we are not migrating for value-added service, voice, and SMS to 5G core. 5G core is there or provides better data rates. However, for typical applications like voice support and all, we are still using the existing 4G network. Now, one possibility is that inter-RAT handover, which can be considered. Apart from that, on 3GPP interface or 3GPP specification group has came up with N26 interface between 4G and 5G core network, which enables a faster handover between technologies from 4G to 5G or 5G to 4G, which helps in better performance, lower latency, improve network capacity, because you can actually use the existing 4G network and services which are deployed and complemented with 5G better data rates also. So N26 helps with better user experience because we'll see how fast handover happens between 5G and 4G by using N26. So uh, key features are, packet routing, which will be through our user plane function, which is a converged node for 4G and 5G. So in this demonstration, we'll demonstrate that our 4G control plane and 5G control plane is using a single UPF, and our multi-access gateway is capable of handling all the both technologies seamlessly. Like we have talked about different approaches. So one approach on the left is where we are using N26 for faster handover between technologies. And there's another approach where we'll use typical inter-RAT handover, which is not the scope for demo today. Okay. So on the left, you'll see there's a four phones which are using different technologies. So the first top one is EPDG or voice over Wi-Fi on the 4G network, and then eNode B for 4G connectivity. Then a third option is 5G connectivity and non-3GPP access, which is N3IWF use case. So our multi-access gateway is capable of handling three different interfaces or three different modes, N3IWF, UPF, SPGWU, and it provides a converged node for better deployment. And our multi-access gateway is release 16 compliant. It supports, like I mentioned, 4G, 5G, and non-3GPP access for 5G node. It is already verified and validated for 200 Gbps aggregated data throughput, and we support different features like IPv4, IPv6 bearer, high availability, lawful intercept, etc., and QoS enforcement also. Now, this multi-access gateway can be configured in 3 different modes: UPF only mode, N3 IWF only mode, or converged mode, where it will handle all 3 technologies at the same time. Since it's a converged node, so it helps in giving better low latency performance between 3GPP and non-3GPP technologies. So we'll walk through the demonstration setup, and I'll request my colleague Neeraj to take over and explain the setup.
Thanks, Ankur. Hi, everyone. Good morning and good evening. Let me present my screen. I hope my screen is visible to everyone. Okay, so let's start with the architecture diagram first. In our lab, we have set up the N26 architecture, or the 5G, 4G, or along with the RAN and the data network in a way. Let me explain it to you. On the left side, you can see we have a VM where we have deployed the simulators, which will simulate the UE, D node B, and E node Bs. In the middle, you can see we have deployed all of our 5G and 4G network functions inside a VM, which are running on Kubernetes platform. Then we have a server where we have deployed a UPF, which is converged UPF, right, which supports 4G and 5G capabilities. Then we have on the right side a data network, which is on another server. So in the core, as you can see in the LT, we have MME, HSS, S gateway C, P gateway C as LT components, and we can call SGWC, PGWC as SPGWC also, right? And on the bottom side, you can see AMF, SMF, and other network functions of 5G, which are all connected via service interfaces and the other interfaces which are mentioned as in the diagram. So let's move to the live demonstration now. So here, this is my master node where we have deployed all of our network functions inside Kubernetes cluster. So let me show you all of the network functions which are running here. So let's start with, like, first of all, you can see here AF, AMF, AUSF, BSF, NEF, NRF, NSACF, and SSAF, NSSF, PCF, SMF, UDM, UDR. These are all 5G network functions which are running on this server. Then in LT, we have HSS, MME, SPGWC. As I mentioned, this comprises of S gateway C and P gateway C. So this is all about the 5G and 4G network functions. These are the databases and other pods which are handling other functionalities like provisioning and all. So now on other server, we have UPF running. So if you want me to show it, then let me present it here. We have all the UPF containers running here. Okay, as you can see, all these containers are running. These are UPF containers. So now let me go to the simulator side. Yeah. So this is our RAN simulator, which simulates our UE, E node B, and the G node Bs. So this is the basic configuration which we have here, and the detailed configuration is inside the configuration file of the simulator. So we are using this MC, right? We are running one UE right now for the handover purpose. And these are all the basic configurations, basic slice that UE will register on, basic DNN, and everything. So let me just go to the dashboard. Yeah. So let's start with the NG setup and S1 setup here. So we are capturing the logs live here. So let me just refresh. So I have just created the ng setup and s1 setup. So from between e node b mme and g node b and amf. So let me show you the logs here. So you can see heartbeat is going on between SPGWC and the converged UPF and SMF and the converged UPF. So you can see here S1 setup and the NG setup communication is done between MME, E node B, AMF and G node B. Now let's continue with the user registration in 5G. I'll start with the registration here. So you can see one UE has been registered to the network, and let me start the PD session establishment now. So PD session is also done. Let me show it in the logs. So as we go here, registration request followed by authentication, security mode command complete, and registration complete. So this is the procedure for registration in 5G. Then after that, we triggered the PD session establishment. After that, so you can see here PD session establishment request coming in from G node B, UE via G node B to AMF. And then PFCP session establishment happened between SMF and the UPF for that PD session, in which uplink PDRs have been created. After that, PD session establishment accept went towards the RAM, and then we got the response, PD session resource setup response, and then PFCP session modification happened, in which downlink PDRs were created for that PD session. So up to here, the PD session establishment has been done. Now we can start sending the data traffic. So let me show you that. We have configured the user plane. Now let me go to the RAN section. So first of all, we'll start the server, which will receive the incoming data on the data network side. We are using iPod for that. So we have started the server. Let me go to the RAN side and let's see the UE IP which has been assigned to the UE. So this is the IP which has been assigned to the UE. We'll use that for sending data. Let me run the iPerf client command here. Okay. I'll just replace the UE IP here with the new UE IP which has been assigned. And I'm running 100 Mbps in uplink. So we have started sending 100 Mbps from the UE towards the data network. You can see 100 Mbps is being sent. And when we will check the data network side, we can see 100 Mbps traffic is getting received on the other end via UPF. Let me show you the UPF pipeline also. So if we see here, we can see incoming traffic has been started. This is the N3 interface in which incoming traffic from the RAN side is coming. It's going all the way through all the modules of the UPF towards the N6 side, which is the core side of UPF. So you can see here, traffic is coming all the way through UPF modules and it's going out through the N6 side of UPF. And as you can see from here, data is reaching the data network. You can see here in 100 Mbps. Now, the data is running now. We'll trigger the N26 handover of a user from 5G to 4G. And data will continue in 4G after the handover. So let me just trigger the handover. Okay. So we'll be triggering 5G to 4G handover. I'm just running that. And let's see in the logs, live capture. Okay, so we can see handover required. So handover procedure is complete within few seconds or within few milliseconds. And let's go through the messages. So here we have all the IPs, like these IPs, I have already resolved their names so that it will be better for our understanding. So similar call flow I have here at the side. So let me explain it to you here. So first of all, from G node B to AMF, we get the handover required message. Then AMF forwards that to SMF. Then SMF sends to SPGWC the create session request. Then in 4G, right? And then from P gateway C to UPF, we get the PFCP session establishment, and then UPF sends back the response for that, and then create session response we send from SPGWC towards SMF. Then comes the forward relocation request, which is sent by AMF towards the MME. Then MME sends the create session request to SPGWC for creating the session. And then SPGWC responds with the create session response message. Then MME sends to eNode B the handover request, and eNode B sends back the acknowledgement for that. And then MME to AMF forward relocation response goes back. Then handover command comes from AMF to GNode B, and handover notify from eNode B to MME. Then again forward relocation complete notification goes from MME to AMF, and the acknowledgement comes back from AMF to MME. And then starts the modification of bearer. So modify bearer request start from MME to SPGWC. Then P gateway C sends to UPF PFCP session modification request, and then UPF sends back the response for that, and then SPGWC sends back the response of modify bearer to MME. Then comes the SMF to UPF PFCP session deletion. So now the 5G PD session, which was there in 5G of that user, it gets deleted once the EPS period is established in 4G for that session. So now PFCP session deletion request and response is communicated between SMF and UPF. Now the session in 5G was which was there is deleted. After that, in 4G traffic tracking area update request like starts, and the tracking area update gets completed here, and then UE context gets released in 5G. So now user has moved from 5G to 4G, and handover N26 handover is complete. So let me just show you that traffic is still running. We are still getting the 100 Mbps data over the DN, and from the RAN side, we can see it's still being sent. So now the data is running in 4G. And let me show you the pipeline also. Data is still running. You can see it here also. So user have moved its session from 5G to 4G via N26 interface, and data is seamlessly being continued in 4G also. So you can see that, and yeah, so that's all about the demo here. And let's move to the question and answers now. Yeah.
Okay. So thank you, Ankur and Neeraj, for the wonderful demonstration. And the chat section was already open for all the attendees. So you can share your questions and either Ankur or Neeraj will answer it. Okay, so I'll be reading the questions now. So first question I have got is, how seamless is the handover process from 4G to 5G, and can it cause any disruption in service or performance for users? And I think Ankur can take this question.
Yes, I'll take this. So when we talk about N26 handover, this is seamless in terms of because control plane of 4G and 5G are communicating and handing over the user equipment or UE, which is a mobile equipment registration. So it's very fast in terms of handover, and across technologies 4G to 5G or vice versa, it takes less than a second, and we have observed and we have monitored that it is completed in 0.005 seconds, the complete handover from 5G to 4G or 4G to 5G. So a user will never actually feel that there is a handover happening whenever we are going from 4G to or 5G or vice versa.
Okay, so if anybody else is having any sort of questions, they can drop that in Q&A section, and we can further take it forward. Okay, so the next question is, without N26 interface, will there be a loss in data, or will it be buffered during handover?
So there will not be any loss of data beyond a point. So when we talk about a buffering or buffering action rule, typically we buffer some amount of data. Here, the main focus is user experience, which is going to be a seamless experience. When we talk about internet handover, and we have seen it in 3G also, that it's a little time-consuming process. In case of N26, the use case arises because there will be a seamless handover between 4G and 5G. So it is not a data loss per se, it is better or faster handover which is required.
Okay, I hope the answer is questioned very well. And so the third question which I have got is, will the video streaming experience be affected during the handover process? Ankur, over to you.
So typically, when we talk about video application, they do have a leaky bucket implementation. So application endpoints also do handle some kind of a buffering. However, from the video streaming, there will not be any kind of a loss of, or there won't be any kind of a delay which will be observed when we talk about N26 handover. It is more for faster communication. So the use case I want to talk about is V2X messages, which are supposed to be very fast, some millisecond kind of a messaging, where N26 can be leveraged. Video streaming is a already solved problem from the network standpoint.
Okay. So the next question is the N26 interface for 4G to 5G handover compatible with all type of devices, including older ones? Ankur?
Yeah, so we have seen it, or we have validated it for most of the phones which are supporting 5G technology, and they are release 15 compliant. So we have taken some phones and we have validated that N26 handover is supported on those devices.
Suppose the customer already has a 4G network and is deploying a 5G network with a new vendor. Do we need any coverage node or existing node, and can new 5G network elements support the handover process?
Okay, so when we talk about 4G to 5G handover over N26, so definitely MME has to support this handover. And for 4G network standpoint, it will be very similar to S10 interface, which is between two MMEs. So from that standpoint, there is a small change required in 4G nodes that can be done through converge node or as well as a modification in existing node. And since 5G, this is already supported in Amantya core, so there is no change required on that part. But yes, definitely there can be different deployment where we have a converged node also if it is a greenfield deployment. But for a brownfield, there will be a change required in MME and 4G core, and after that N26 interface will be supported or handover will be supported.
Okay. The next question is idle mode mobility also possible for using N26 interface?
Yeah, let me answer this question. So yes, it is possible.
Okay. So the next question is how IMS core will be integrated with 5GC? Ankur?
Yeah. So IMS core will be integrated in the same way it is integrated with 4G also. However, what we are observing in different deployment at different service provider, there is no rush or there is no installation where we are seeing IMS getting integrated to 5G core for any brownfield deployment. What we are observing and what how operators are doing it is that IMS integration is with 4G, and all the IMS related features and functionality is supported either via N26 or internet handover.
Okay. So I think we have covered the questions now, and unfortunately we are running out of time. So we have few more questions which we have noted down and shall answer them offline. So I would like to thank Mr. Ankur and Mr. Neeraj for their time. Also, I would like to thank everyone for your participation. And if you have any remaining questions left, I would like you to drop them in Q&A section so that we can answer them offline. Thank you.